All right, so hopefully everyone's got the interface here loaded up. And again, as I said, there are control panels on the left, the map and the right, and then in the middle. And what we'll see eventually are both usage options and then time series plots on the right. Okay, so what do we do here? Well, the first thing is to sort of get used to the way this functionality works. And as I mentioned, this is all of our chapter focuses on this app, but behind the scenes are all the scripts that get called to run the algorithm. And again, you can find those scripts on our GitHub guidebook, probably in many other places as well now too, that actually allow you to do this programmatically. But this allows us to play around and visualize different options. So the way that this works is if you go on the left and you click on the little double sort of arrow things next to any one of these titles. I'm going to click next to the land trender options. It'll expand out on the left and you'll see a bunch of options that you can play around with. If you want it to go away, you click it again and it goes away. If you click on one of these and then click on a different one, it'll close the prior one and only allow one of them to be open at a time. The key thing about this interface, which is really handy, is that when we get to the fun stuff later, like making maps of change down here, the change filter options, these are all based on the recipes that you've put together for the land trender algorithm up above. And so what this encourages is experimentation with, let's find the right way to capture the change in the Landsat record. Let's find the right way to parameterize the algorithm to find it. And then once we've got all those pieces, then we can do stuff, can make maps. But again, all of that first set of steps, those are all the temporal segmentation pieces. All right, so this in the chapter, we go through this in some gory detail, and I want to just kind of walk through an example of how to do this here visually, because I think the visualization actually helps quite a bit. So the first thing to do is to decide how we're going to build a set of images, a time series of images, to hand to the algorithm. So we think back to the figures I had just a few slides ago. The land trender algorithm accepts parameters and it accepts image collections. And so we need to build an image collection where each year has, for a given pixel, each year just has one value. And when we build that collection, we take advantage of the many tools on Earth Engine to look at multiple images within a season, for example, compress them down to one composite image, the best one we can get, and then from that calculate an index. And so when we think about that within a season, within a year, that window of time, we want to base that off of some reasonable seasonality in your part of the world. So in the map interface, you can zoom into where you're interested in, and I'm going to just go to Oregon because this is a place that I know. And I would encourage you to just pause for a second, watch me go through this, and then once I've gotten to a point where we can stop, I'll ask you to do the same in your part of the world. But if you just watch for a second, this will be useful. So I'm going to go to a place that it's kind of easy for me to explain because it's a fire that we know about. And so this is, I'm working in the map interface in the center. I'm just clicking and dragging sort of like we might normally do on any slippy map. And I'm going to zoom into this place that on the underlying image on Earth Engine, we would look at and we see that this looks pretty much like a big scar in an otherwise green landscape. And this was a fire that happened about 15 years ago, or a little bit more than that now. So the first thing we want to do is we want to define the total range of years that we want to run the algorithm. This is a really important step for one main reason. This algorithm, like a lot of the time series algorithms, is data hungry. And by that, I mean, even if you're only interested in change from, let's say, 2015 to 2022, if you only run the algorithm for that amount of time, it does not have enough information to make good decisions. And what I mean by that is that the algorithm is simply using statistical decisions to say, here's what normal looks like. It has that year-to-year variability caused by all those things I described earlier, sun angle, vegetation, phenology, atmosphere, et cetera. It needs to know what the baseline looks like to be able to tell if there's something interesting that has changed. So again, even if you're only interested in a map of 2015 to 2022, you want to go back as far as you can in the Landsat archive for your area of the world. So some parts of the world, don't actually have a very good Landsat record until Landsat 7 begins in 1999. Others have gaps, et cetera. Fortunately for me, I'm just going to max out what we've got here in Oregon. I find that we do have images going back to 1984. That's our default. That's the beginning of the Landsat thematic mapper record. That's as far back as we go with the current version of Landtrender. But I'm going to move this up to 1986 because we have the luxury of many years now, and sometimes the 1984 and 1985 images can be a little squirrely. Okay, the next really important decision is the date range within each year. So we're building image composites within a date range of each year. We're going to use something called the metoid compositing approach, and you can Google that if you want. I won't go into that in detail, but essentially it's trying to find the best pixel from within the year. And I'm going to pick a date range that works for my part of the world, and apologies to those of you internationally who are used to the day first and the month. We do this month-day, so this is going to be, I'm going to start on 07, so that's July. I'm going to start in the middle of the month, July 15th, and I'm going to end at 08/31. And so what I've defined here is from July 15th, August 31st, is the range of dates that we're going to accumulate images from the Landsat archive, put them together, smush them down into a single composite per year, and then go on to the next year and repeat that for all the years to build our basic image collection. Now, in choosing this is one of the knobs that is the most important often in terms of defining whether a signal in your part of the world works. You've got to balance three different things. The number of images, because the more images you have to work with, generally, the better you can make a composite that does not have clouds. So the second thing is clouds. So if you have a very cloudy, rainy part of your season, and you only give the algorithm, let's say, a month of imagery to work with, it may never find a good value for a pixel because the clouds have been masked out, and you only have clouds. Now, the third thing is seasonality, because you might have a certain vegetation signal, let's say, that only happens when at maximum green up, or maybe at the dry part of the season, for example, or the cold part of the season. So this decision really is the first important decision that hinges on your expert knowledge of your environment that you're interested in. So in our case, we have a dry season in the summer. So July and August are pretty reliably clear. So there's not a lot of clouds. It's not always, things have already begun to senesce. So there's not a lot of greenery if you're looking at vegetation. But if I'm looking at forests, this is great, especially evergreen forests, because then the distinction with the background is quite evident. I'm going to pick that. And the next thing is the source spectral index. And these are a bunch of abbreviations which you can Google or look up. I realized in a training workshop last week that we didn't have these adequately described. I apologize. But these are indices derived from spectral bands on Landsat. NBR is a normalized burn ratio. I'm going to use that. It leverages the shortwave infrared and the near infrared, but NDVI, many of you are familiar with that. That's also an option. The TCs are tassel cap, brightness, greenness, and wetness. We do give you the option of working with the raw bands. These are expressed in terms of Landsat 7 bands. So band 1 is blue, band 2 is green, etc. I would avoid the what we call normalized ones here at the bottom. They're there if you want to play around with them, but you actually would need to look in the code a little bit if you're that advanced and sort of understand how those work. So I'm going to stick with NBR for now. And this actually affects a bunch of the mapping options later, but it won't affect, we'll have more options to do this when we look at our pixel time series. So that's one important thing. And I'm going to leave the segmentation parameters alone here. And I just want to show you what happens, and then I'm going to change the segmentation parameters. So if I take my mouse and I just click somewhere on my map with the left-hand click, I'm going to click, and when you click, we don't have a good little like timer thing spinning or anything. It will take some time for it to run, and what it's actually doing is it's submitting all these parameters to Earth Engine, and it's building image collections, running the algorithm, et cetera, and spitting things back. Although I think maybe because I'm on Zoom, let me try this again. It takes a little bit of time. And if we want to see what's going on, I'll just make sure that there's no annoying problems. All right, so I forgot one important piece. So we have to actually define all of our parameters here in the land render options, but to actually get the thing that I want, which is a time series, we actually have to go down to the pixel time series options in the control panel on the left. So you click on that. And so again, what I did here is I just clicked on the little dots next to the pixel time series and expanded those. It automatically collapsed the land render options. Those are still, the ones we set are still valid, but this is just giving us the option to run the pixel time series. All right, so in this case, we've got a bunch of indices that we can check, little check boxes. Right now it defaults to NBR. I'm going to add in NDVI here just for comparison. And we'll leave the rest of the pixel size alone and the longitude and latitude. Instead of typing them in, I'm going to suggest that you just click, and this is what I intended to do on the last second, but if you just click somewhere on this image, then it'll submit everything to Earth Engine and then spit back a time series for just this one pixel. It might be kind of small, but if you look closely, you can see a little red dot has showed up on the map, and this indicates what that pixel, the pixel that is being run and reported on in the time series on the left. So I want to draw your attention then to the time series on the right, and this is the same thing that I show in the chapter. And so we're going to work with this basic premise, but the way these work, on the x-axis we have the year, one number per year. On the y-axis we say spectral value, and we have a generic term there because the actual title on the top of the graph, in this case NBR, or the second one NDVI, that indicates which spectral value it is. Those of you familiar with NBR and DVI know that these are decimal values that range from -1.0 through 0 up to 1.0. But working with floating point data is sort of unnecessary precision that doubles the amount of space. So we translate everything and we scale it by 1,000 in this case. So a value of 1,000 on this graph would be the equivalent of an actual NBR or NDVI of 1.0. So with both of these indices, NBR and NDVI, a higher value suggests more vegetation, lower value suggests less. The gray values on these graphs are the measured values from the instrument, okay? And so they're bouncing around, as you can see. The red values represent the way that the temporal segmentation algorithm has characterized that particular trajectory. And you can see just right off the bat here that the trajectories of the gray values this is the same pixel just looked at with two different spectral indices. These tell a different story, right? In the NDVI record here, we have a drop, a pretty precipitous little drop in about 1993. And that was enough to make the algorithm think that it was interesting. I want to pause though and not have you look at the red lines quite yet. What we want to focus on are the gray lines, which are the original measured values. And so, excuse me, if I just compress the pixel time series and I go back to the line render options, and if I change my date range, and I'll do this from January 1st to February 15th, which is a dark, cold, rainy time of year here. lots of clouds, and certainly different conditions on the ground. I'm going back to my pixel time series on the left, and now the pixel that I just chose is the one whose latitude and longitude show up here. So if I want to rerun the same pixel rather than having to try and find the same location, I just say submit pixel, and it'll submit back to the latitude and longitude that I picked. So all I've done here is I've changed the date range that I want to use for this pixel to see what happens to the gray lines. So I say submit pixel, should run, and as you can see, several different things have happened. For one, the gray line does not have nearly as much temporal articulation. So it goes from, for example, 1996, and it actually skips a bunch of values and goes to 2000. That's because in between those years, it didn't find a good non-cloudy image. There's just too many clouds for this region for the time period that I picked, which was January to February. And this signal that I'm looking at bounces all over the place, but the signal of change, well, maybe I can convince myself that in the NDVI record, in the gray line, it's there. But this is a fairly non-informative signal for this particular location. So what I'm interested in having you do, we'll pause the recording for a second and let people play around with this. First, go to the land render options, find some place in your part of the world that you want to look at. And based on what you know about seasonality and clouds, play around with the date and year range. The year range might change if you're in a part of the world where the older Landsat archive is pretty sparse. Start with 1986, but then you might have to move it up, and then define a date range that is of interest to you, ideally, again, with relatively few clouds, but where the condition on the ground is still interesting to you. So just leave all the rest of this the same. Once you've got those set, then go to the pixel time series. You can just leave it with NBR, or you can add a couple more if you want to click on other boxes, and then just in your map, navigate to your place you want, ideally a place maybe where you even know about a specific change that's happened. Click on the map and wait for the charts to show up. Look at the gray line, play around with it until you get to the point where you think hopefully the change that you're interested is actually detectable. So we'll pause the recording, let people play around with that for a little bit, and then come back in a second.